I'm now going to remind you about composition of functions because this is going to be really important. So if I want f of g, that means I'm using the outside function of the f, and then I'm going to be putting the g inside everywhere there's an x, and that's as far as we go. So then the g of f of x is going to be taking the outside function of the cosine, and everywhere there's an x, I put this root x plus 3 in. So let's try another one with the trig function. So f of g of x is, so I'm going to take the outside function of the tangent, and then it's of 1 over x squared, right? Because that's the angle. Every trig function has to have an angle. And then here, I'm going to take the outside function of the g, so I'm just going to write that outside framework, and then put the tangent of x inside. And I just want you to be aware, this means the same thing as this, right? Okay, let's try this one. So if I do f of g, so f is the outside function, and then I'm going to put the cube root of x in for everywhere there's an x. So you know, I just want to remind you that when you have this fractional exponent, it's power over root. So this could be rewritten as this. Not necessary. I'm never going to be a stickler about how you write the answers. Just want to remind you of things. So g of f of x. So g is the outside function, and then I'm going to put f of x inside, and that's as far as it can go. No more simplifying there. Then this one here, so just make sure you're thinking about how it's read. ln of x, sine of x. So if I want to do f of g, so that's ln of sine of x. No parentheses needed because ln has to have an inside argument, and that happens to be sine. So g of f is going to be the sine of ln of x. So again, it's not multiplied. That's an inside function. No parentheses needed. Okay, so now you're going to be the creative mathematician, and you're going to think of, okay, what would the functions be if I had this capital F written as an f of a g? So hopefully you can see the most outside function is an e to the x, and the inside function is 5x squared. This one could be done several ways. I'm just going to offer one. So the outside function I could use as 1 over x, and then the inside function I could use x cubed plus 4. It's okay to have another answer also. Just make sure you're not having any one of the functions just be x, because that would be pretty simple stupid, right? Okay, so this one here, you know that this can be written as secant of x all squared, right? So then the outside function would be x squared, and the inside function would be secant of x. This has this radical on the inside of the trig function, so the outside function would be the cotangent, and the inside would be the root x. Okay, here we go with 3 layers. We can do this. So I want an f and a g and an h. Again, none of them can be just x. So thinking about it, I'm pretty sure ln of x has to be the most outside function. Then I'm thinking 1 over x is the next layer, and then the most inside layer is x plus e. This, I'm just going to rewrite it just because I want to make sure you see this is the same thing as saying the cosecant of e to the x all cubed. So that tells me that the outside function is the cubic. The next inside layer is the cosecant, and then the h of x function will be the e to the x. This one here, you can kind of tell as you read it. Cotangent of ln of pi x. So the outside function is cotangent of x. The g of x is ln of x. And the most inside function is pi x. All right, let's stop there before we move on to this difference quotient.